Welcome back, multivariable class. I hope everybody's doing well. I've got two more review topics to cover this week. The first one today is going to be on inverse trig functions and integrals of those. It all starts back with taking derivatives, remember. But since the derivative with respect to x of arc sine of x, I'll remind you of those, is equal to 1 over square root of 1 minus x squared. And the derivative with respect to x of the arc cosine function, same thing except a negative sign. Okay, so because of that negative sign, we'll only have to learn 3 of these derivatives, or antiderivatives. Okay, still need all 6, so I'll let you refer to your notes on what the derivative of arc tangent is, arc cotangent, arc secant, arc cosecant. But since the derivative of the arc and their co-friends are just the negative sign, we're just going to learn 3 integrals. So I'm going to use du functionality. Du a squared minus u squared, but the square root of that, well, that's going to be arc sine of u over a plus c. Integral du again, all of these have fractions, all of these have a squareds and u squareds in them. This one, however, no square roots. It's just a squared plus u squared. Du on the top, that's going to be 1 over a arc tan of u over a. So all the arguments have the u over a, but arc tan has 1 over a out front, arc sine does not. And the last of the 3 integral patterns that you need to remember, the weird one, I guess you'd say, because we've got that u out front. This is square root of u squared minus a squared. Remember, it really matters. U is some function of x. A is going to be a constant. Okay? So this is out front, so it pulls the u squared out front of the square root. This one, there is no square root, and we're adding, so there's no order. It could be u squared and a squared. It's a squared plus u squared. It doesn't really matter the order there. Clearly, the order of subtraction matters. This is also going to be 1 over a out front, arc secant. And if you recall the derivative, we needed the absolute value. With this one, we need the absolute value on the integral side, the antiderivative side, not the integrand side. Absolute value of u over a plus c. All right, so we'll do a couple examples, and I've got a worksheet for you to do, and you can do that. Integral of, let's say, 5 over square root of 9 minus x squared. Well, that 5 is just in the way. Hopefully we can see that that's u squared. The x squared is u squared. That means u equals x. That means du equals dx. And I know for some of you that looks boring to write all that out, but in the long run, you won't make the mistakes, especially with your du, if you remember to do, still got it, that. And then that means that a squared equals 9, so a equals 3. This subtraction order, the 5 is just in the way, so we're going to bring that out there. Isn't that just going to be arc sine of u over a, and the du matches the dx. I guess I need to write my dx in there, sorry. So my du matches my dx there, so that's no problem. U, which is x, over a, which is 3. And that's your argument of the arc sine function. And don't forget plus c. Another one. E to the 2x, because a lot of times we see these, for some reason, e to the, with these arctans, so just to keep it fun, e to the 4x. Well, in this set, it would make sense that this has to be arctan, because there's no square root, and there's a plus, and this could be a u squared, and this could be an a squared, or vice versa. Well, this is going to be my a is 2. I think we can all see that. If u squared equals e to the 4x, u, square root of that, the 1/2 power, right, is going to be e to the 2x. What's my du? Well, my du is going to be e to the 2x times 2 because of the chain rule, dx. So I'm going to squeeze in a 2, and I'm going to squeeze in a 1/2, and I need to finish my dx. Sorry, I got excited to continue on to the next problem. So 2 e to the 2x dx, 2 e to the 2x dx is my du. So this entire term up here is du. Okay? A squared plus u squared, we've got everything we need. 1/2 from this 1/2 here. But oh yeah, we need 1 over a times 1 over a, which also happens to be 1 over 2, times arctan of u over a. E to the 2x over 2 plus c. You could simplify that to be 1/4 arctan e to the 2x over 2 plus c. All right, another one. So we'll number these 1, 2, 3, an integral. Let's try 1 over x square root of 4x squared minus 1 dx. Now, a lot of times people want to say this right here is the first thing they get triggered on. U equals x. Well, maybe, maybe not. If I say u squared equals what? Looking at my integrand here, this is u squared minus a squared. So if u squared equals 4x squared, I wrote du, but I really mean u. U equals, what's the square root of 4x squared? Well, 2x. What's du? Aha, 2 dx. So we need to squeeze in a 2. We need to squeeze in a 2. Okay? However, if you put in a 2 right here, 2 dx, I'm good to go. But I need a 1/2 outside, right? Not so fast. What is that term right there that I just underlined? It does have x, right? Because if you look at your integrand rule back up in your notes, this has to be a 2. Aha. So 2x times the square root. So really we don't have the 1/2 and the 2 there, do we? Okay? So keep that in mind there, that didn't need that. All right? So we've got that 2. So we've got what now? Those 2's really divide out. Our answer should be 1 over a, which is just 1, right? Because a squared equals 1, so a equals 1. 1 over 1 times, and just for fun, I'll throw in one of these, right? Secant to the -1, arcsecant, absolute value of 2x over 1. Again, that 1 was kind of not very interesting, so we could write it like that, or just secant x, secant absolute value, there we go, of 2x plus c, or inverse secant if you want. I like arcsecant better. Okay? I've got other examples in my notes, but I kind of want you to think about these and do these. I'll do one more because this is a good reminder that sometimes we have to split up the terms. So these can be challenging problems. The integral x minus 2 over x plus 1 squared plus 4 dx. X plus 1 quantity squared plus 4 dx. Now, if I were to just think of this as an arctangent, because clearly there's no square root, that's probably our first guess. If I tried to think of this as an arctangent, then u squared equals this, then u equals x plus 1, du equals dx, and I have an extra x. Oops. Right? So that didn't work. If I think about this as u prime over u, right? Expand this out, I would have a 2x or something up here, but then I'd have other terms maybe, and I'd have to simplify that too. So maybe we're going to have to break this up. Let's break this up into x over x plus 1 squared plus 4 plus integral just -2 over x plus 1 squared plus 4 dx. This one, I hope you would see that would be pretty simple to do, right? Because we've already walked through this half. This is x plus 1 is my u squared. This is my a squared. So u equals x plus 1. Du equals dx, negative 2, no problem. However, since we've got an x up here, I'm going to have to expand this one out a little bit. So let's rewrite this as the integral of x over x squared plus 2x plus 1 more is 5. And then I'm just going to leave this negative 2x plus 1 quantity squared plus 4 because I'm hoping to do arc tangent for this second integral. This first integral, I'm hoping that you see what I did there? You see something you should still be able to do. X squared plus 2x plus 5 du equals 2x plus 2. All right, well, I can squeeze in a 2. But if I squeeze in a 2, I'm going to squeeze in a 1/2. But wait, for my whole du, I need plus 2. So plus 2. I can do that, right? 2x plus 2. Because I got the rest of this, and I could add a little bit here and subtract a little bit here and see which, make this new numerator to offset this, because I'm adding some here, I'm subtracting. Did I just add a 2? The answer I hope you all see is no, because of this 1/2 out front. So if you redistribute this 1/2 x, 1/2 times 2x is x, 1/2 times plus 2 is plus 1. I need to subtract 1 over here to offset me adding this 2, which really is 1/2 of 2, and it's offset by that minus 1. Okay? So, I hope you could all see this one now. This is just going to be 1/2 natural log absolute value of x squared plus 2x plus 5. Okay? Or you could go back to this into this denominator quantity x plus 1 squared plus 4. But, this is fine. Okay? But then I've got minus 2 minus another 1 is actually minus 3. There's my a. So here, u equals x plus 1. Du equals 2. Let's say du equals dx. A equals 2. Right? A squared equals 4. A equals 2. So 3 over 2, right, times arctan of u over a, x plus 1 over 2 plus c. So that's that integral there. All right. So some good reminders, good practice. These are good problems. This, again, will be a place that you'll want to be able to do off at the big school next year. All right. So this is one of our topics that will be tested on Friday. Inverse trig integration. The other one, so I'm going to put up a worksheet. You can do that and practice that today and tomorrow. And then on Wednesday, I'll put up another lesson. This will be on trig substitution. And if you remember, that's actually pretty challenging. I'm not going to say difficult because you all got A's in BC last year, didn't you? Didn't you? Yeah, a lot of you did. But we'll review that on Wednesday. That's what this quiz will be over this week. You only have one daily grade each week. Your daily grade this week will be on Friday's quiz. I will probably get those quizzes written sooner than later, so you'll have easily by Wednesday. If not tomorrow, you'll have those available to you. So you can do those at your leisure, but I'll have them due Friday at midnight because I don't want you spending time over the weekend. I think a lot of other teachers might be putting things due Sunday because you've got the weekend. Well, if I make everything due on Sunday, then that's the only day you do something. So I'm going to make them due Friday. I'm going to stick with that because, wow, it's just one daily grade. You can do it. Si se puede. Si, yo tengo que puede. Not asking for much here, so you got to do something. If I seem a little cranky, yeah, whatever. Do something. I'm trying to help you prepare. Do something. All right? If you have friends that have not taken the quiz yet from Friday, and as of this morning, there were 3 of you that hadn't done it. So proud. He says not really that proud. Get them on the stick and tell them to do something. It's their life. I'm not going to chase you down. I'm done coddle babying you. You're either going to do it or I'm going to put in a 0. It's easy. All right, so do something and then do some practice. I'll talk to you soon. If you are having actual issues, please talk to someone so we can help you. Still want to help, but I also still want to get you ready for the college of your choice, which many of you at this rate will not be ready if this is the leisurely frame of mind that you're going to have for the rest of the school year. It's going to be hard to get out of that lethargy next year. SAT word for you, lethargy. Have a good one, and talk to you soon.